Rhode Island, master's degree in environmental science from the University of Colorado Boulder, where I focused in urban resilience and sustainability. I'm joined by Kelsey.
Yeah, I'm Kelsey. I'm the community engagement manager for Flatiron. Prior to Flatiron, I was the external affairs manager for South Coast Wind, actually, for about 5.5 years. So I have a lot of experience in offshore wind community engagement and looking to transition that or support the battery storage industry as we have this pocket of growth. I studied chemistry at Clark University out in Worcester, and then I got my master's in sustainability science at UMass Amherst. So Massachusetts through and through, but I also did a lot of work in Rhode Island on the South Coast Wind Project. So I'm here because I believe this is a key piece to our clean energy transition, just like offshore wind. So I've been on the team for about 3 months, and it's been great to chip away at everything we have to do.
Yeah, I can kick us off, and then I'm going to pass to Kelsey. And I probably should also tell you what my role is at Flatiron. I just skipped right over that. Kelsey's going to give you an intro on who Flatiron is. But at Flatiron, I'm a partner developer, so I manage our Massachusetts portfolio of early to mid-stage development projects. We have a handful of projects in Massachusetts, which are really important for Rhode Islanders as well because of the interconnectedness of our grid system. So we're going to kind of use a case study of our project in Somerset, Massachusetts, that's currently under development and in active permitting. That's called salt cod storage. So we'll refer a lot to that project. But we do have other projects as well around the state. Salt cod is particularly interesting because from an electrical interconnection perspective, it's very relevant for the South Coast Wind Project. It's actually one substation away. It's sited on the other coal plant location in town. So it has just a lot of similarities, and electrically relevant. Our battery will actually be able to store energy produced by South Coast Wind. So I will pass it off to you, Kelsey, to kind of kick off who Flatiron is. And then we do have some materials up here. I have a few books that I find really interesting. I will say the first book is about just really dry about battery storage, but if you do want to learn more, they're great resources. And then we do have a 1/40 scale model of a Tesla Megapack. So I can pass this around while we're getting started. And then feel free to grab the books if you want to flip through them. Kelsey, take it away, please.
Yeah. So as Hannah mentioned, and I guess I'll just off the top. Here we go. Who we are. And just off the top, we don't have too many people in the room, so I'm happy where you can take questions as we're going through this, if that makes sense, and happy to pause for the Zoom if there's questions. But yeah, definitely happy to pause because we'll be going through a lot of material. But just starting off with who Flatiron is. Flatiron Energy is an exclusive utility scale battery storage developer. So we're an energy developer, just like an offshore wind or a solar developer, but all we do is develop utility scale battery storage. That varies in amount of megawatts, but I typically like to think around the range of 200 megawatts, just to give you a sense of where we're landing. So we are primarily focused on the Northeast region for a number of reasons. So that's our ISO New England market, which our grid that all 6 New England states share. We're also focused on the New York ISO operator, and then PJM is a new market for us that we're exploring. So we're focused on the Northeast, as I said, for a number of reasons, but some of the main reasons are because we know the energy is needed here. We're continuing to retire fossil fuel generating sources in New England and across the eastern portion of the United States, and we need to replace those sources with new energy. We also know that these states are supportive of renewable energy and the clean energy transition. They want new technology to shore up our grid system. Massachusetts, for example, recently upped their target of battery energy procurement to 10 gigawatts by 2035, which was a double in their procurement target. So battery storage projects are becoming an increasingly critical part of our grid operators infrastructure when it comes to reliability planning and thinking about our overall transition and meeting our goals. What we also know is that permitting can be difficult in these Northeast states. What's, interesting about this area is how densely populated it is. We're looking a lot at industrial sited areas that are already disturbed, which is great for a lot of reasons, but it makes permitting complex. There's not a ton of land, as we know, in New England, so permitting is complex, but with support and knowing that there's a need, that's why we're going for it in this area. And just talking a little bit about the great team. As I said, I've been on the team for about 3 months and it's been amazing. I've been super excited to land on such a talented team. But just to touch on our leadership team, so we have 4 members of our leadership team who have been working together for over a decade. Together, they have developed more than 20 battery storage projects that are now in operation. So there's lots of experience in our core team. There's about probably 50 employees at Flatiron Energy now, and we're continuing to grow as targets for battery storage continue to grow. But we do have a sound track record when it comes to energy development. A lot of our team members come from other industries like Hannah and I, offshore wind or onshore renewables. So yeah, we have a great team. And I should mention that Flatiron is based out in Denver, but we have an office in New York and an office in Boston. And as I mentioned, primarily focused on the Northeast area. So that's Flatiron. And at the end of the presentation, as mentioned, I'm going to get into the specific salt cod project. But before that, I will pass it to Hannah just to talk a little bit more about the basics of this technology. And as I mentioned, this is the good part, it's the meat. So feel free to ask any questions.
Yeah, we do have a lot to go through. One other thing I'll add about Flatiron that I think makes us really stand out amongst other battery storage developers. Flatiron is B Corp certified. B Corp, if you're familiar, is anyone familiar with B Corp certification? Okay, so B Corp certification is a voluntary standard, but it's a really high standard that's governed by the B Corp entity. So you actually have to prove you're doing certain things related to social governance, environmental sustainability, and your people structures, essentially. So it's all about the triple bottom line, people, profits, and planet. And I know just having from my experience working in the renewable energy industry, I don't know any other renewable energy developer that is B Corp certified. It's also a accreditation that you have to maintain. So you have to be reaccredited every 3 years. And you have to achieve a certain score on all of the different categories to achieve that certification. So it really speaks volumes to our approach to battery storage development. And as Kelsey mentioned before, we do target industrial sites. So we really don't focus on greenfield sites. We focus on already developed sites. The salt cod storage project that we'll talk about today, this is a picture of it on right over here, is at the former Montauk Power Plant in Somerset, which was decommissioned in 2011, but still has storage infrastructure that was left abandoned there. But before we get into all that, what is battery storage? Often referred to as BESS, battery storage is large rechargeable battery systems that store electricity for later use. There are various types of battery storage systems. Lithium-ion batteries are the most common in utility scale applications. We are utility scale battery storage developers, but there are other applications of battery storage. So you could have a mega pack in your home that is powered off of the solar panels on your roof. That's a very different process, a similar technology though, similar manufacturers, a very different use case. We're here today to talk about utility scale battery storage because it is critical to combating climate change and for our grid operators to manage the system effectively as demand continues to grow with additions of data centers, additions of population, and with our aging infrastructure not being maintained or replaced. People are often welcome.
This is Bosworth.
People are often confused when they hear lithium ion and then they hear lithium iron phosphate or nickel manganese cobalt. So lithium iron phosphate or LFP and NMC or nickel manganese cobalt are subchemistries of a family of batteries that is lithium ion batteries. That's a big point of confusion and misinformation in the battery storage industry. Lithium iron phosphate is the market leading technology that we use today. It is safer. It has a higher temperature for thermal runaway, which is fire. So it has a lower fire risk. It has a longer lifespan, a lower cost, and it does not contain heavy metals. Nickel, manganese, cobalt, or NMC, on the other hand, has higher energy density and it performs better in certain climate conditions, but it does contain heavy metals and there are other supply chain issues associated with NMC. NMC for a long time was dominating the market. From like 2010 to 2018-ish, that was the leading chemistry. And you did have a higher rate of fire incidents associated with battery storage projects. So a lot of the misinformation, a lot of the claims we hear in the battery storage industry about they're not safe, there's all these fires, that was really tied to the chemistry that was used at that time. But also, we'll get into this a little bit later, the lack of fire code for these systems. And all of that has changed. So the industry has come a really long way in just the last 6 years, and more importantly, like the last 8 years, as fire code has caught up. So a little bit on the history of battery storage. I won't go too deep into this. You guys can read this slide on your own, but I just wanted to show that battery storage has been around for a long time. People and often will claim that, oh no, batteries are such new technology. And yes, they have, as I mentioned, come a long way in recent history. They've actually been used in multiple applications for quite some time. As I mentioned, lithium ion battery pack costs significantly dropped in 2010, 2020 timeframe, which brought more projects onto the market and really made it like economically viable to have commercial scale utility battery storage. And today we have over 150 gigawatts of total installed capacity of utility scale battery storage projects. That's enough to power 120 million homes. So now we'll get into kind of like what makes up a battery storage project. So these are like some typical features I'll talk about. Again, this is a visual rendering for our salt cloud storage project. So you have the Taunton River. This is, if you're familiar with Somerset, the Montauk Power Plant. This parcel here is where the fuel tanks, they still are there. So if you drive on County Street today and you look to your right, you'll see the two really rusted out fuel tanks that used to store millions of gallons of fuel that powered the generators in the power plant. So typical components of a battery storage system. Every project needs a point of interconnection. So that's where it plugs into the broader transmission system. Utility scale battery storage systems distinguish themselves from like microgrids or the types of systems you might use in your home because they connect to the transmission system, not the distribution system. The distribution system is what powers our homes and our businesses. You can think of it as like the local roads, and the transmission system are the highways. So the transmission systems are critical, right? We don't get power to our local roads without the transmission system. Utility scale projects plug into the transmission system. So you can see the power lines coming in. Well, I have a little, let me turn it somewhere. You can see the power lines kind of coming in like over here. That's the existing infrastructure. Then there's this tower here. It sends the high voltage system that then goes across into Fall River. And there's an existing substation right there where it says point of interconnection. That's the Pottersville substation. It's owned and operated by National Grid. Every project has to connect somewhere on. It's either connecting into an existing substation like you see here, or it's doing what's called a line tap, which is when you're connecting directly to an existing transmission line and building a new substation to facilitate the interconnection. Every project will also have a switchyard. That is the infrastructure that takes the power back and forth from the batteries and is the in-between from the switch, the point of interconnection and the battery system. It will do things like change the voltage of the power that's coming in, change the frequency, things like that to keep, to step it up where it needs to be to go across the broader system. And then the little rectangles are the battery enclosures. Somewhere over there is the example I passed around. And then you have usually like maintenance buildings. Sometimes you have some additional storage facilities as well. Battery projects do not have a lot of maintenance. They have like folks coming in to check on the site every now and again, but they're really low impact in terms of like traffic because they are automated, a lot of the components of the battery storage system are automated, and they're also monitored remotely. So they're really low impact. We like to say that like once a battery storage system is up and operating, you won't really know it's there. For this project in particular, you can see along the street here, we have landscape buffers. That's just to align with the local zoning code, but we do always do some sort of beautification around our projects if they are within viewshed. And then we have a sound barrier here. Battery storage systems do produce noise. They produce like a whirring from the fans that are part of the HVAC or thermal management system in the battery enclosures. But the noisier component is actually that switchyard. So within that switchyard, there are transformers. Those produce a good amount of noise. So not all projects need sound walls or sound barriers. It really depends on the location and the exact topography, as well as the operating conditions of the batteries. And then there's some nuances too between different like products on the market, like a Tesla product, which is that the example I passed around, or a Fluence product. They produce different noise levels. And then every jurisdiction is going to have different bylaws related to noise that's what the allowable levels are. And then every state may or may not have noise bylaws as well. In Massachusetts, the DEP, Department of Environmental Protection, does have noise limits. So those sound barriers help ensure we are compliant at all times, even under the hottest temperatures where those fans are running in the battery system, that we're fully compliant.
Can I ask a question?
Of course.
How does that noise compare to like the fossil fuel infrastructure they're replacing? Like, how does it compare to the substation noise or the former gas?
That's a great question. I can't speak to the gas plant. I'm not familiar with like what type of noise. I would assume the noise from the gas plant would be more associated with like increased like traffic. A lot of people work at coal plants. There's a lot of like moving parts and equipment, but because they are usually housed within, you know, a building, I assume that would block most of the noise. But I actually always tell people, like, if you want to know what this project might sound like, go stand next to a substation. It's like a low humming or whirring noise. Yeah. The limits in Massachusetts, and this is a pretty common, Massachusetts is the most stringent I've seen for noise regulations, but they require you can only go above 10 decibels above the ambient conditions. So we actually go out, we monitor what are the ambient conditions, and then they have really stringent requirements for like how you get to that ambient. So you have to remove like, you have to use the quietest hours of the night. You have to monitor for a certain period, usually over a week. You have to remove any like insect noises or noises that aren't consistent. And then you're only allowed to exceed above, or you can't exceed 10 decibels above that or create any pure tones, which are like nuisance noises, like a whistle or things like that are a higher pitch. I'm not a noise expert, so don't quote me on that, but generally speaking. So what we also like to, with this project in particular, the noise increase is about 7 decibels. And that's similar to like the total noise production from the site is within like the 50 decibel range, which is just above, I believe like the example is a dishwasher running in a room that you're not in. So like if you're standing in, you know, your living room, your dishwasher's running in the kitchen.
Do you guys have an OEM selected for this?
We do not yet. We are going through a competitive bid process right now, actually. We have signed a project labor agreement though. So inside of the battery enclosures or containers, as they're often called, there is, people often refer to this as like, what's the architecture? How are the systems organized within the enclosure or the container? So it starts at the cell level. On my right, you can see the battery cell. That is much bigger than they actually are. Many battery cells are organized into a module in the middle here, and then the modules are organized onto racks. As you can see, there are 2 racks there. This is a pod, so it's like a certain amount of racks enclosed in a system. With the Megapack, they don't use pods. This Fluence product, which is another manufacturer, they use pods. So there's different like terminology with each product, but generally they're all going to be cells organized into modules, housed in racks, all within the enclosure. And you can actually open the doors on that little guy and see. Okay, looks like you guys did. Battery storage systems also have robust built-in monitoring, smoke, fire, smoke and heat detection, and thermal management systems. This is all to ensure these systems are safe. And even in the worst case heat conditions, or if there's a malfunction, that there are no thermal runaway incidents. Thermal runaway is when a battery enters a state of overheating, it'll begin to off gas and then it can catch fire. So all of the systems today are designed in alignment with National Fire Code, whatever the state fire code is. So for this project, Massachusetts fire code. And there's also UL certifications that both the battery cells and then the entire enclosures have to go through as well. So they do large scale fire tests. It's very robust systems to ensure the safety of these products. And again, that's a really big difference from what you saw between like 2010 and 2017-ish. So these are some of the systems you'll see. These are the like hardware systems. There's also software systems. So the software systems, well, they're combined with, so those are like the hardware components on the last slide. We have also hardware and software systems that work together to monitor the functioning of all the way down to the battery cell level. So we have what's called an energy management system. You can think of that as the brain of the battery. It controls charging, discharging, and it protects the equipment. The energy management system monitors the battery's health and performance and reports data in like, I believe it's 5-minute increments. It might be even shorter than that, back to the remote operation center. The remote operation center are where the batteries are remotely operated. It manages the operation safety for the battery system. And there's actually subject matter experts who are certified to be behind those monitoring screens, and they watch the projects 24/7. There's also 24/7 central station monitoring. So these are a separate monitoring that is also remote, but they're watching all of the security and fire alarms, and they would be responsible for any sort of escalation of the systems. So you have like a physical person behind a desk, but a lot of the alarms are automated as well based on certain systems, and that's where like the software and the hardware come together. So this kind of flow chart just shows how those systems work together. We have direct monitors, or certain alarms will go directly to your emergency responders. With certain products, you actually have 2 separate entities monitoring the energy management system as well. Like Tesla and Fluence, they both offer their own remote monitoring in addition to the operator that we would hire as well and be contracted with. So more often than not, you actually have 3 separate remote monitors watching the battery storage system at any given time. They also have like automatic shutoffs. So if a cell is overheating, that battery module can be turned off automatically without intervention. I'm not a fire safety expert. I will say this is also another avenue of battery storage that you can get really technical and really deep into. Flatiron has a director of fire safety, and he sits on various boards and is far more in the weeds than I am on this. I know enough to be dangerous though. So further on-site safety, outside of the enclosures and outside of the software and hardware systems, you have like the on-site safety features. So we have water supply. We work directly with fire departments and the public utilities to ensure adequate water supply to all of our sites. The this is referring specifically to salt pad project, so we have numerous, those are the street references. We also want to make sure there's numerous access points to the site, so first responders can enter and exit the site at multiple locations. We have cameras for physical security, to ensure, no one's messing with our project sites. And then there's, alarms on the enclosures as well. So if there ever was an incident, it would be very easy to identify which unit was involved. As we talked about, there's 24/7 monitoring. And then every year we have site inspections, and you'll do a full safety report and code compliance report every 3 years. And then another piece of misinformation we hear often is related to environmental compatibility. People claim that battery storage systems can pose a threat to the environment if there's a fire incident. People claim that, it can cause a lot of pollution. I think people get that information because they think of like a lead acid battery that the electrolyte can actually spill out of. That's not the case with these systems. They are IP rated systems, so water cannot get in, and there is like physical containment on the bottom, so it can actually hold if anything were to spill, which what you're concerned with spilling in a modern battery storage system is actually just the coolant from the HVAC system, which is the same kind of coolant you'd use in your car. The bottom of the container is designed to capture, if there ever was a coolant leak, all of the coolant in the system. It would also create a ticket to our report operating center, so they would catch it ideally from the automated systems if there was a leak, but under a worst case scenario, all of the liquids could be captured.
Can I ask a
Yeah,
question?
definitely.
I'm curious if your safety studies of the battery systems have included when in the rare case that they combust and are thermal runaway, what emissions are given off by batteries, especially the newer ones?
Yep.
That don't have heavy metals, like what is present in those emissions?
Yeah, so when there are battery fires, it's consistent with the same emissions from any sort of structure fire where you have burning plastics. So there's not actually really any unique properties that are in the plume of a battery fire that you wouldn't also find in any other structure fire. Any of the toxic properties that are in a plume are associated with burning plastics. That's another point of misinformation that we hear often. People think like, and I understand because I didn't know this either until I got into this industry. But people think like there's this unique threat from a battery storage fire, and there's not when it comes to like the plume and the consistency of that plume. So what we'll do is we have to do plume studies where we look at how the site is situated, and we'll hire a consultant who models what would happen in a thermal runaway event. They use data from the large scale fire test that the manufacturer will do, and they use that data to inform what would be in the plume. They look at like the topography of the site, the wind conditions, and they actually have to prove that even in like a worst case wind day, that the plume would remain localized.
So is that about it not being more toxic? Is that true of the nickel magnesium?
Sure. Yeah, we can just jot that down. I can look it up. I'm not sure. I would assume it's different because there are heavy metals, but I don't know like what happened. I'm not a chemist either. I don't know what happens when you burn those heavy metals. It's important to also remember that because of the architecture of the enclosures, when they do these large scale fire tests, what they often see is the fire event remains in one module. So often it's not actually spreading between modules. To pass a large scale fire test, they actually have to show and prove that a fire does not propagate between units either. So within the enclosures, there's fire breaks. With the Fluence product, which we'll show in a minute with the pods, there's 4 pods that sit on top of a skid. Each pod would, only the pod, like one pod where a fire started, the fire would be contained to that pod. So to pass the fire test, they have to prove it doesn't propagate to the next pod. It's a little different in the Tesla unit. It's like a whole half that would be consumed in a fire. But yeah, it's really interesting how they engineer these enclosures to ensure there is no propagation between units. Another, piece of misinformation we hear often, there was a fire recently in Westport and people were trying to compare that to a battery storage fire. And again, you really like the unique characteristic of a battery storage fire is more to do with the duration of a fire event, where you could see a fire burning for longer periods because the like best practice for fire management or response is to let the system consume itself and burn out. So that because the electrical fire, it can burn for longer durations than a typical structure fire, which they would just apply water to and let burn itself out. With an electrical fire, with these battery storage systems, they can burn for longer periods of time. And so looking at different layers of protection, as I mentioned before, we're not just focused on like how we design the site. It's from everything from product design and manufacturing all the way through training and operations. So on the screen under testing and certifications, that's a list of some of the certifications that battery storage projects have to go through. As I mentioned, the Underwriters Laboratory or UL certification is one main manufacturer certification. And then the fire protection systems we went through, that's just a list of some of those systems. Through past incidents, there has been a large focus on research and development as well, and that's led to a lot of the safety improvements we've seen in battery storage systems, along with the chemistry changes as well. And then quality assurance, all of the testing and certifications are third-party verified from independent engineers. Then we go into local codes and standards. So we do have to adhere to both local building code, fire code, and electrical codes. Our systems are designed safely. They are designed based on guidance from NFPA 855, which is the relevant national fire code. So that establishes distance between units and things of that nature. We will also produce fire-specific or site-specific safety documents. So we'll do hazard mitigation analyses, we'll produce emergency response plans in collaboration with our local fire departments, and we'll do those PLIP studies that I mentioned. And then we do have to go through local permitting processes. Massachusetts is transitioning into a state permit process, but all of these things will still be true under a state permitting process. Rhode Island also has a state permitting process for battery storage systems, similar to Massachusetts. It's through the Energy Facility Siting Board. And then at the project level, we are training our first responders. We're making sure that they are not, they are ready for before we even build the system, they understand what the system is and how it operates, and they're prepared if there ever is an incident to respond. So that is what the ERP covers. We will also hire subject matter experts. So part of the monitoring that I mentioned earlier, the monitoring of the emergency response systems within the battery enclosures, that's done by a third party, and they do like our whole safety package. So they'll also host the trainings for the fire departments and things of that nature. And then we will have decommissioning plans in place. So after the useful life of the facility, it can be, the battery enclosures can be recycled, and the site will be returned to its previous condition.
What's the lifespan of the batteries?
They're warranted for about 20 years. A lot of projects though will be repowered. And I expect over time the warranties will go up as well. I think you might be able to get like 25-year warranties today. So getting into like, why does this matter, right? Before I go too deep into that, I just want to like level the playing field on our energy systems. So we are in this part of the world on the Eastern Interconnection. That is one of 4 independent power grids that operate in North America. Within the Eastern Interconnection, there are numerous independent system operators who manage our grid system. In New England, our grid system is operated by ISO New England. They are a nonprofit and they're responsible for both the high voltage transmission system and the energy markets where our power is bought and sold. And then within the ISOs, you have your retailers or utilities. Sometimes your utility is also your retailer. That would be like National Grid or Rhode Island Energy. They are ensuring the electricity is actually making it to your home, and they are managing the electric systems. They work really closely with ISO New England to dispatch power and ensure it's going where it's needed at any given moment in time. So we're getting real technical here. If you look at the top left, we have a graph. This is all data from ISO New England. I would recommend, if you're interested in getting like really deep into this, ISO New England has amazing graphics and amazing data available to the public. But on the top left, ISO New England data on firm generation over the last, from 2017 to 2023. So what we've seen is an increase in firm demand, meaning more people needing power over that period. We have an increase in variable supply at the same time. So while that's great, we all love renewable energy. We've seen in the interconnection queue, which is the process to bring a project online, mainly renewables in the last 6 years and going forward. And again, that's great for meeting our climate goals, but it does pose challenges for our grid operators because our renewable energy systems are intermittent resources. They're not available all the time. What that does when you have increasing demand and a supply that's more intermittent is it increases volatility on the system. At the same time, we have decreasing firm additions. So there aren't new firm generators or non-intermittent resources, our traditional fuel sources, coming online, which again, from a climate perspective, is a great thing. But we also have our existing generators that are providing firm supply that's available at any given time. They are retiring, they're aging out. Again, climate perspective, we love to see it, but that does decrease reliability. So together with increasing volatility and decreasing reliability, we have this critical need for capacity that is both clean to meet our renewable energy targets and mitigate the impacts of climate change, but it also is reliable and available at any given time. And that's really where batteries come into play. That's exactly what they can do. These are non-emitting, non-polluting sources of energy that can provide it back to the grid within seconds when it's needed most. So as I said, with increased reliance on intermittent resources, we need to capture that excess energy. Intermittent resources like wind and solar are really effective. They're actually producing surplus energy very often, which is great. But some of that can go to waste. So batteries can capture that excess energy. They charge during periods where usage is low or demand is low. That tends to be in the middle of the night. That also tends to be when our offshore wind is producing the most. They then discharge, sending power back onto the grid at periods of high demand. That's when our grid is the most strained and costs are the highest. If you look at the bottom graphic here, so just to make it clear, like where we're plugging in, back to the analogy I gave previously of the local roads and the highways, the transmission system is where we interconnect and exchange power. So generators for a utility scale standalone storage project, generators supply power onto the transmission system. We charge and discharge from the transmission system, which then feeds into the distribution system and then goes to the consumer. Crazy thing that I think a lot of people don't realize, I didn't know this until I got into this industry. Our grid relies on frequency and voltage that are consistent at any given time. If the frequency or the voltage on our electric grid is out of whack or not consistent, it causes disruptions in our electrical service. That can mean blackouts and brownouts. That can mean failures of generator systems or failures of the transmission system. And all of that equates to cost to the consumer. Battery storage systems within milliseconds can balance frequency and voltage on our electric grid. Typically, that service is provided by peaker plants, which again are the highest and most pollutive generators on our system. They're also the most costly. They're only operating for a small period of time every year. So our battery storage systems help stabilize the grid, prevent blackouts and brownouts, and eliminate the need to rely on pollutive peaker plants. And a little fun fact, the top 10% of peak demand hours represent 40% of Massachusetts' annual electricity costs, and that equates to over $3 billion a year. I'm sure in Rhode Island, it would be a very similar figure. And as I mentioned, fossil fuel peaker plants only operate a few days each year, but they account for over 10% of Massachusetts' total greenhouse gas emissions. Again, that's going to be a pretty consistent figure when you're looking at Rhode Island. And the Department of Energy Resources estimates that just 600 megawatts of battery storage could deliver $800 million in benefits to Massachusetts ratepayers. And sorry, I am very Massachusetts focused. I'm not a policy expert in Rhode Island. You're gonna have to go to Christian for your Rhode Island policy questions. But focusing on Massachusetts because it does matter for Rhode Islanders, because our electricity systems, our grid does not know state boundaries. As part of Massachusetts energy strategy, energy storage has been identified as a critical component to meeting growing demand, supporting reliability, and reducing energy costs. They have set a target to deploy 10,000 megawatts of battery storage by 2035. And today in the Commonwealth, there are over 6,000 battery systems that are connected to the grid, operating at about 500 megawatts of capacity. These do tend to be smaller systems, so the projects you're seeing coming on, like the Salt Pad project, are larger than what we see in the Commonwealth, but there are a handful of large utility scale projects as well.
How many megawatts is this all from?
168. So again, battery storage stabilizes costs for residents by lowering overall energy costs during periods of peak demand. It's storing power when it's lowest cost and then dispatching that power back when electricity prices are highest. So I highly recommend, again, you go to ISO New England's website and you look at the information they have on how they dispatch their energy on different markets. But generally speaking, they're using what's called an economic dispatch model, where they're dispatching the lowest cost generators first. So what that means is as demand increases incrementally over time, they're turning on more generators to meet that incremental increase in demand. The last generators that are coming on are the most expensive, and they tend to be the most pollutive because those are the peaker plants. So battery storage, what it does, it can actually, by having a lower cost product on the market, you're knocking off that last generator from coming on. I know actually you all at Carrie have some awesome slides I saw over the weekend on this. And then we already talked about how these reduce reliance on those peaker plants. It also eases congestion. On your electricity bill, you'll have like transmission charges. Those are the fees for maintaining the transmission system that your retailer is passing on to you. By reducing strain and preventing blackouts and brownouts, we're able to reduce the costs of those transmission charges as well. By capturing extra or excess solar and wind energy that would otherwise be wasted, we're also preventing those generators from being curtailed. And then we're overall improving grid reliability, helping avoid outages, and those costly emergency scenarios like blackouts and brownouts. Kelsey, do you want to take, I think this is, yeah, do you want to take over from here?
Sure, I can go through this one quickly. So I think this is kind of a wrap up of what Hannah was talking about, but as climate action folks, these are some of the misconceptions that we hear as we're working to educate people. I do think, you know, just like offshore wind a couple of years ago, there's a lot of education to do around battery storage in our communities, and people aren't, not all people are coming from a place of, automatic opposition. I think there is real fear and real, education to share. So misconception number one that I think we always hear and is always the tone of a lot of rooms that we are in are that battery energy storage systems are unsafe. And as Hannah went through, there are multiple layers of protection, lots of people behind these projects that are thinking about how to build these in a safe way for the community, how to build them in a sustainable way so that these assets are operating in our communities for 20 plus years, as Hannah mentioned. And the industry standards around safety continue to be improved as more and more of these projects are permitted and allowed to come online. Misconception two, utility scale battery storage fires are common. Definitely not true. We see a lot of, scary images and photos, videos online of battery systems on fire. Often those are stories of the worst case scenarios that happen with outdated technology. So again, as we, create lessons learned, as we take information from those worst case scenario situations, technology continues to improve. Everyone, including developers and communities, are getting more smart about this, and any type of fire is becoming way less common. Battery storage facilities create significant noise. So as Hannah mentioned, they do create noise. They are part of our transmission system and very similar to a substation facility, but it's not creating, deafening noise. It's not creating noise that really is any different from electrical infrastructure that we're already living with in our communities that we live next to now. And lastly, and I'll go into this a little bit on my next couple of slides, which I will go through quickly knowing we're coming up on the hour, but battery storage projects don't benefit the local community. Definitely not true. Battery projects, as Hannah went through, have lots of benefits when it comes to reliability, when it comes to making sure that we're using the most of our renewable energy sources. But they're also, we're building things. They're creating tax revenue. As Hannah mentioned, we have signed a project labor agreement for the Salt Cod project, and many developers are continuing to sign project labor agreements to make sure that we're paying prevailing wages to union workers. And also these projects come with host community agreements and pilot tax agreements. And there's opportunities for communities to shape these projects to their needs, making sure that the host community is contributing to priorities, but also doing things like creating landscaping plans that work for the community, thinking about walkability in these areas and how we can improve things like that, so that we're a long-term partner for decades. So quickly, I'll just go through the Salt Cod project. Now that you all are, super educated on BESS and understand what it is and why we're doing it. Here's a project that Hannah and I are spending, I'll say, most of our time on these days and working hard to, get it through the local permitting process. So this is in Somerset, Massachusetts. As mentioned, it's at the old Montauk Power Station. So this parcel up here on the right-hand side is the actual power plant that you'll drive by. And as Hannah mentioned, you can see on this aerial view the two fuel tanks that are still existing on that site. Right now, although we have an option to lease both of these parcels, we're focused first on that parcel on the fuel tank site. And then we have an option to potentially do a second project where the coal facility sits, but lots to figure out. As you know, it's a, historic use of that site makes it complex. So we're chipping away at it piece by piece. As Hannah mentioned, it's a 168 megawatt project. We are planning hopefully to start construction in June of 2027, which would allow us to operate the project by the end of 2028. So just to relate it to offshore wind, these do have much shorter permitting processes. Each local permitting process for these projects can be different when it comes to timeline. And as Hannah mentioned, we're transitioning to the EFSB process in Massachusetts, which will take somewhere between a year to 16 months. But regardless, having come from the South Coast Wind Project when I was working on permitting for 5.5 years, and it's been being permitted for about a decade now. we can permit these projects, you know, in under 2 years, which is really exciting. All of the permitting happens at the local and state level, so it's a great thing to keep in mind, given the times we're in. It's a lever that we can pull now in the next couple of years, which is really exciting. So just talking a little bit more about the Somerset site. This site is an ideal site for battery storage. The proximity to the load center, so you know, it's in a dense area. As we mentioned, we need energy sources like this in Massachusetts, and it's right near an existing national grid substation that we're able to tie into the transmission system. Our, you know, project proposal is also consistent with the historic use of the site. It's an industrial site. It used to host oil and gas infrastructure, and ideally, I would love to see this site and other sites in Somerset be kind of leaders of the clean energy transition, and it makes a lot of sense for this site, and there really is kind of limited reuse just given everything that has happened at this site the past couple of decades. It's already disturbed, so you know, we're not doing much other than cleaning up what the site looks like now. It's already really well established for us to essentially put down a bed for all of our batteries. And hopefully through all of this work, really will be improving the view shed, will be improving the overall site conditions for the folks that live around this site, because it's sort of in the middle of Somerset. So yeah. This is a, you know, aerial type of more engineering view of what the project looks like. So that again, you can see very lightly the fuel tank circles in the background there. But in blue is where we're planning to essentially set up all of our battery units. This 168 megawatt facility will have about 9,800 units. Oh, look at that pointer.
Good stuff.
Oh, look at that. Oh, yeah. We'll have about 98 units here. It does depend on the technology. Actually, I can just go to the next slide. It's gonna work. So recently, as mentioned, we're in the plan development process with the town of Somerset and the zoning board in particular in Somerset. And as we've been going through this process, we've been taking feedback from the town and the fire chief. And like other energy development projects, as you're developing the project and going through permitting, you narrow down on your engineering designs and also your supplier selection. So there's a number of different battery suppliers out there. Tesla and Fluence, which is a Siemens product. Many of you have probably heard of Siemens, are the two types of technology that we were looking at for the Somerset project. We recently made the switch from Tesla to Fluence, and you can see the difference in the number of units. I don't remember how many units were actually here, but you can see it significantly reduced the footprint. There's pros and cons to, you know, both of these different technologies. This one helped us in Somerset because it gave us more room for the fire department to stage how they would want to in an emergency situation. The Fluence units are a little bit taller than the Tesla units, which changes some things like noise, where we'll have to redo our noise study. But there's lots of different factors that we have to consider when making a supplier selection. Each project is different, and we go through a rigorous supplier selection process to make sure we're really considering all aspects of the site and picking the technology that works the best for us and also the community that we're in. Fluence Smart Stack, that is what we're planning to use in Somerset, as mentioned. It's both the Tesla and Fluence have the battery chemistry that Hannah mentioned, the lithium iron phosphate. The Siemens has been, you know, developing energy technology for decades, if not, you know, 100 years. They have been developing battery technology for a long time. Fluence Smart Stack is really their latest iteration of their battery technology and the latest and greatest that they have in the market. So we are working with this project. It is going through fire testing now and will fully have passed certification, of course, by the time we have it on the ground in Somerset. But as mentioned, the technology just keeps getting better, and we're excited to use this project.
And you can kind of think of it like, so this is a Smart Stack V2, similar to Tesla had their Tesla Megapack. Now they have like the Megapack 3, I think they're on. You can think of like your smartphone, right? Every iteration. So there's high confidence. They already have passing fire safety tests from the V1. They've made some structural changes to maximize the energy density. That's why we saw a reduction in the amount of enclosures we actually need and could reduce the footprint, because these new products have a higher energy density. So it's not like this is a brand new thing that hasn't gone through these fire tests before. It's just the next version of the same product.
Is Fluence, sorry, is Fluence a domestic, is it gonna be a domestic product? Yeah.
Yep. Yeah, so the enclosures are integrated in the US.
Okay.
The battery cells are manufactured abroad, but all of it is put together in the US. And they are starting, I believe, to manufacture cells more in the US.
It's 168 megawatts. Given that these are more energy dense, did the megawatts for the project increase, or are you limited to that, or?
We're limited to 168 megawatts because of the interconnection process. So we have to go, before we select a supplier, submit our interconnection applications and choose, a capacity at that point. The capacity that we choose is typically based off of the available capacity at the existing substation.
Great. So just the project timeline, as mentioned, we're in the permitting process. We have been doing lots of community engagement in Somerset and are on our third zoning board meeting, and hopefully we'll continue this process and get it wrapped up by the end of the summer. As Hannah just mentioned, we're also in an interconnection process with ISO New England, where we're, figuring out all of the final upgrade costs for us to be able to connect to that infrastructure there. And then also this project was already awarded by Massachusetts DOER for a contract with the state. But just like offshore wind, permitting, transmission studies, procurement with the state, that's all happening at the same time, kind of three lines of effort that are all looking at the same timelines to hopefully end up financing the project early 2027. And as mentioned, construction is fairly quick, about a year and a half, and we're hoping to operate this project by the end of 2028. Construction and then operations and maintenance. So safety, just to say off the top, is our highest priority when it comes to contractor selection. We haven't selected an OEM yet, but we have signed a project labor agreement, which we are very excited about. The construction hours will be compliant with local ordinances. There's really nothing too special about this construction when it comes to 24/7 construction or anything like that. No crazy traffic impacts. The biggest traffic impacts will be bringing in all of the different containers by truck, but a very temporary, short disruption to the community. And then, of course, we'll have lots of mitigation measures on site. That is part of, the permitting process we're going through with the town now. But of course, we'll have dust control, given the historic use of the site, traffic control, and we'll keep the community up to date on all of this. And hopefully, we like to tell people the construction is really the worst part of it. It's a year and a half. We'll get through it together, and then it's for the greater good. And then for O&M, the great thing about these projects is, as Hannah mentioned, if everything goes right, which is what we're designing it to do, you really won't know that it's there. So it doesn't require any type of maintenance. You're really only going to see personnel on site for, every so often check-ins. So no traffic impact. Sound will be compliant with state and local regulations and will continue to be monitored. But as we mentioned, very similar to a substation. We'll be monitoring the site 24/7 along with our third-party contractors. And of course, we will keep these sites secure, just like any other, energy infrastructure that you might see along the side of the road, gated, very secure, and hopefully really not bothering anyone. Project benefits, Hannah went through, improved grid reliability, of course, improved health. So where decommissioning and cleaning up some old fuel tanks, hopefully improving air and water quality in this area. Also lots of economic benefits. There's the project labor agreement, which will come with more than 100 union jobs, increased tax revenue, opportunity for Somerset to design a host community agreement. So hopefully we can be a good community partner and, provide benefits to the town for hosting this project. These are some cool pictures, just to show you what the site looks like now and what we hope it will look like. So this is a picture of the fuel tanks in Somerset now, if you were to drive down County Street. And this is the rendering that Hannah has shown that we hope it can look like. So there will be the sound wall here, which will help residents with the noise. We'll work with the community on a landscaping plan that fits in with the character of the neighborhood. And ideally, again, we're improving the view shed, we're improving the overall site conditions. Ideally even giving some more green area, maximizing our setback and minimizing our footprint for the project.
Yeah, and just to note, this is actually the rendering with the Tesla product, so there's many more containers than we would expect. So the setbacks are a little different than what we showed previously.
And this is just the street view, same thing. So as you can see, I mean, when you're not a bird flying in the air and you're just a person walking on the street, you can, hopefully the sound wall is 24 feet high, so you're really not seeing the units. Ideally, you're far away enough from the units that you're not hearing them and you're just walking around your neighborhood and not knowing it's there, but getting clean energy from it. And community engagement really quick. So we have been and will continue to do lots of engagement with the Somerset community and any community where we're building a project. Very, very similar to offshore wind community engagement that you guys have been involved in. We'll continue to host office hours and open houses. We have been doing a lot of door-to-door outreach, sending mailers to residents, creating websites. As mentioned, there is lots of education to do around battery energy storage. There's lots of scary information that's shared on Facebook. So I encourage you all to, we can be a new source of information for you all on this. Climate Action Rhode Island is certainly doing their homework and looking to provide resources to its members on this, but definitely encourage yourself to get educated, to be able to engage with your neighbors on this, because it can become an emotional issue. People are scared and people do deserve the real factual information to create their own opinion and ultimately decision on this. But we appreciate your support in just educating communities and our neighbors so that they can understand the benefits ultimately.
Did you encounter much organized community resistance to this?
Sure do.
Yeah.
Same people that came out for South Coast Wind
Yeah.
have, shifted their attention to the new shiny thing in town.
Yeah.
I won't name names, but they are there and they are challenging.
Yeah, I think battery storage is definitely it's the next thing to focus on. It's certainly associated with renewable energy for a reason, because we're making the most of it. And it's also, development, which scares people. So yeah, the organized opposition that has been growing around offshore wind and, has been growing around offshore wind since the Cape Wind days. I think, this is a new thing to focus on as the federal stuff has kind of quieted down. So yeah, we really do appreciate your support and have to get organized on the other side too, for sure.
Do you have any examples? Hey. Do you have any examples where
Sorry.
you worked on? Oh, can you hear me?
Yes, sorry.
Oh, okay. Hey. Do you have any examples of projects where the goal, the initial plan was to work on a site, so it's kind of a centralized plan, but ultimately kind of hearing feedback from communities you've elected for decentralization. So it's kind of like it's really a question about the trade-off of economies of scale versus the interests of communities.
And I guess, what do you mean by decentralization? Because we are taking feedback and changing our designs based on community feedback. That's
Decentralization of sites. So So yeah, I mean, you can have a single site, or you can decentralize it, which and I'm learning about all this stuff on the fly. So there's sort of a trade-off in terms of uh, I think it's a energy and power trade-off. But on the flip, so I mean, simply like if you have a big site, let's just stick to one issue. If you have a big site, you create a lot of noise. But if you decentralize it, you lower the amount of noise, and it also, if you think about it, it places less of a burden on individual communities. So you put a big site, there's more of a burden. If you decentralize it, you spread it out. So I guess my question is, have you worked on any projects where you started out with a centralization mindset, and you've shifted to decentralization?
I don't, I can say no, we have not.
Okay.
There's a number of things that would prevent us from doing that, though, mainly your interconnection agreement. So you really can't stray from your point of interconnection. And when you talk about like spreading out a system, so let's just use a simple example. If we took all of the battery containers that were on the fuel tank at the power plant, and instead we said, hey, we're going to put 10 here and we're going to put 10 down the, a block away and then 10 another block away. It's really not feasible from an interconnection perspective. Every roughly like mile of transmission you have to develop to connect all of those batteries together to then feed back into the grid is roughly $1 million a mile. So it quickly destroys the economics of a project to have long transmission systems to connect the power back to the grid. So that's really why you see these projects located really close to existing grid infrastructure, either a high voltage transmission system or a substation.
Thank you.
Yeah, of course.
Are you thinking, this is gonna lower costs to consumer or because of the variability?
I wouldn't say it lowers costs because our gas prices are like the dominant factor on the market right now, and those are going to continue to be volatile. But what it does do is stabilize costs. So you'll see a reduction of cost on the wholesale market because we're knocking off those most expensive peaker plants, but you won't see like on your individual rates a reduction because you're still getting those transmission charges, and you're still getting those like trickle down effects from the retailer. And gas prices are going to continue to be volatile and subject to socioeconomic conditions. So we like to say like stabilizes costs. More reliable power, and like ideally you would see, because of the reduction, like the less likelihood of blackouts and brownouts, that's where you could see a cost savings. But again, it's not going to be like a line item on your bill. And it all funnels through the retailer. So it is hard to measure exact impacts on the transmission costs. We just know we're preventing blackouts and brownouts. And if there were to happen, you'd be charged for them.
Have you seen like a community scale of these projects? So, I know there's a lot of communities who are investing in these solar projects to benefit the local community, and thinking about alternative models to like relationships with the energy companies. And so I'm curious, like similarly, if you see a use case for that, like a community investing in a battery storage system for the municipal area.
Definitely. There is an example of that in Massachusetts. I'm blanking on where it is right now. I was looking into this like a few months ago. I can follow up though. There is an example of that with one of the co-op utility or retailers in Massachusetts. They have like a system they partnered with the community, and they're usually much smaller systems, and it's not providing the same benefits because they're not participating like on the whole, like they're participating in different markets. It's like a different type of project, but it definitely has like a backup generator benefit for the local community. And then if you have structures in place where you can buy into that and reduce your retail bills directly, it definitely has advantages, but like very different from utility scale.
Do you think construction of these projects could reduce like performance-based incentive rates for residential energy source systems like in the future? Because if there's more like batteries to take from for the grid during high stress periods, do you think it could reduce the amount that they rely on residential batteries?
I don't know that the grid is like the wholesale market is reliant on residential batteries. That's a tricky question. I don't think I know enough to answer that with any degree of confidence.
Okay.
It's a good question.
Yeah, if you want to send us an email though, we can like talk to our team about that. We do have like experts who might be able to answer it, but yeah, generally like my understanding is residential is just such a small piece.
I'm just curious about the name, Flatiron Mountain, isn't that near Boulder?
Yeah.
And that's where the
Yeah.
National Wind Energy Test Lab is?
Correct. 3 of our founding partners are from Colorado or lived in Colorado when they founded the company. And just interestingly, the folks that founded Flatiron, one guy, our chief operating officer, he's from the Cape, grew up in Barrington. So real like local guy. The other 3 partners lived out in Colorado. They all worked at Engie together. Engie's a really large renewable energy company. And they decided like, hey, we could do this. There's a market opportunity here. Nobody's entering this market. The ISO New England, like nobody's citing battery projects in Massachusetts and Rhode Island and Connecticut, New York City, because it's so challenging.
Yeah.
It's such a tough regulatory place to cite a battery project that other developers are going for the lower hanging fruit, whether that's like developing in Texas where there's no permitting or just choosing, you know, friendlier places. They really like had this niche approach, and just another like testament to their success here. Like they started this company in 2021, so like shortly after COVID, not an ideal time to start a business. And our first project is in construction now, slated to be operational at the end of the year.
So I hear there's a proposal for utility scale battery in Quonset Point,
I have heard, yes.
and it's getting some opposition. Do you
I have
know
seen.
much about that project? And
I read a couple of articles on it after they had a recent like community engagement that stirred up a bit of press. So I don't know much about it. I am not familiar with that developer either. I believe their focus is more on solar. Interestingly, the developer's name is also Hannah, so fun little consistency there. But I think it's earlier than our Salt Cod project. And I interestingly have seen some of the same opposition, the organized groups whose names I will not mention, but I have seen some crossover. So it is like a very small pool of people fighting for this and a small pool of people fighting against it.
so so Massachusetts, you said there's a goal of 10 gigawatts. So is that goal in legislation, or what I'm wondering is there legislation in Rhode Island that you would like to see submitted and passed?
Yeah, and that's a good question. So it is in the legislation in Massachusetts. It is, it wasn't part of the Climate Act. I don't think it was more recent. So originally the procurement targets in Massachusetts were actually lower, and just probably 2 or 3 months ago now, they increased it to the 10 gigawatt target. I think it was 5 before. In Rhode Island, I'm really not sure what currently exists, but given like I haven't seen much development aside from this one project, I would guess it's not much. But would obviously be really excited to see some positive legislation. I do believe though Rhode Island has portfolio standards or, you know, targets for both climate neutrality and or carbon neutrality, and I assume they have renewable energy targets as well, given their interest in offshore wind.
So Glenn also had a question if Flatiron has any plans for Rhode Island.
Yeah, so I do a lot of renewable energy for commercial and residential across Rhode Island and Massachusetts. And this is a great presentation. And I know that Massachusetts, when you look at on a per person basis, the goals set by the states are a lot more storage than Rhode Island. But Rhode Island is definitely got some goals. And I was just curious if Flatiron has plans to do a project in Rhode Island.
We don't currently have plans to do projects in Rhode Island, but we are prospecting new projects all the time, especially because the next interconnection cluster opens this fall. So now is the time where we're looking for new sites to add to our portfolio. We would be interested in projects in Rhode Island. I believe at one time before I started with the company, we had like a lease agreement on a property, and I'm not sure if it was a regulatory issue or an interconnection issue that paused that development, but we've definitely like dipped our toe in the water. And again, I'm not super familiar with like the political landscape in Rhode Island right now. I'm a bad Rhode Island resident. I'm just getting involved with Carrie though, so you guys will turn me right.
Yeah, cool. No, that's
but I'm
good.
focused in Mass, definitely open to Rhode Island prospects though.
Awesome. I think the state would have some good prospects for you guys.
We have about 10 minutes more left in the room, so I don't know how much more of the presentation.
I think there's
Oh, I think we're,
Oh,
yeah,
yeah, perfect.
totally done. I was just gonna plug our community giving program. So if there happen to be any Somerset organizations or really any nonprofit organizations that are serving the Somerset community. So maybe there's Rhode Island organizations that are serving Somerset. You're welcome to apply to our community giving program. We open it 4 times a year. This round is due on Monday, so it's a little late notice, but I will say the application maybe takes like 15 minutes to fill out if you're focused, so it's really not too bad. And yeah, definitely encourage you to apply. This is our way to kind of put some lines in the water to understand community priorities and needs and get to know more people. So yeah, please feel free to apply if you or share it with organizations that might be interested. And that's that. That is my email, so please do write it down. I put some cards over on that table too. Hannah and I are around and clearly renewable energy and battery storage nerds. So happy to talk to anyone at any time, especially if it's, you know, helping you get out there in our communities and talk with your neighbors about battery storage. That's really what we want. So appreciate your time and really appreciate this invite.
And I will say our next zoning board meeting is July 16th. If anybody cares to see us in action and maybe get bullied a little bit, feel free.
We are looking for support always in Somerset, so thanks.
Great.
Awesome.
Thank you so much.
Thank you.
Thank you.
Thanks very much.
Thank you.
Yeah.
It's a few books up here if anyone's interested. You're welcome to take a look through them. This one's pretty cool.
All right. Thanks all.
Engineering.
Thanks. Thank you.